got oh, she's So what we're going to do is we are going to stick Dolly into a replica of the vacuum of deep space. Scientifically known as she's, oh gosh, she's a bit ugly, isn't she?
I'm going to give you nightmares.
It's like The Exorcist. Put Dolly into the vacuum of deep space. Well, it's not really, but it's as close as we can get in a laboratory. And this thing is going to draw the air out. It's going to make the pressure lower in here. So let's see. Can you see Dolly's head?
Yes.
Let's see what happens when we... That's what happens to you if you go into space without a spacesuit. Everything that can expand expands, and it comes out all the holes you've got. Your brains and stuff, and all the fluids come out your ears, your nose, your eyes. You have space jobbies curly whirly out your bum. Really, really cold. Let's just switch it off there. There are other problems as well, because space is very, very cold. And because it's very cold, we need to find out what's going to happen to things when we make them cold as well. And scientists do all sorts of experiments to try and copy, to replicate the cold of space. And we can try and copy the cold of space here using this stuff, some liquid nitrogen. And this is the same stuff they use in hospitals to freeze your warts and verrucas off. It's a bit weird, it looks very much like water. It's very different to water. I don't know if we can get it on the mic, but just the heat from my hands makes it boil. But this is not boiling hot, this is boiling cold. Different things boil at different temperatures, and this is boiling at nearly 300 degrees Celsius, colder than the temperature. Isn't it hilarious how when Dr. Bunhead hurts himself, burns himself, and jumps on? That's the most important part of the show. Now, even the heat of the floor makes the stuff boil and evaporate and go back into the air where it came from. In fact, even the heat in the air, just get a little bit more of it, will make it boil, evaporate, and go back where it came from. So since we've got this cold stuff, we can look and see how things change when we cool it down. So I've got a balloon here, filled with air. Oops. What do you think will happen to the air in the balloon if we cool it in the liquid nitrogen? Sorry? Will it all go away? It might go away, yes? One idea, what do you think? Will it turn into liquid oxygen? A good scientific thought, perhaps. What do you think? Sorry? You mean get smaller? You mean decrease in size? You mean reduce in volume? You mean contract? What's your name? Simon Stupid. Don't feel sorry for him, that's a ridiculous idea. Now Simon thinks that if we pop the balloon in this liquid nitrogen, it's going to shrink. Now as we all know, I am very clever and Simon's stupid. So it's not fair of me though, as a scientist, to say that Simon is stupid. I have to do an experiment to prove it. So prepare to be humiliated, young Simon, as the balloon explodes spectacularly in the liquid nitrogen. 3, 2, 1, bang! Bang! Did you mess with my balloon? It shrunk. That's weird. I mean, it warms up, it gets bigger again. Now, Simon, just because something happens once in science doesn't mean anything at all. In science, we have to repeat our experiment, so I'm going to repeat the experiment. This time, I'm going to completely immerse the balloon in liquid nitrogen. This time, it will definitely explode. It's getting colder and, oh dear, colder and smaller and, oh dear, oh dear, oh dear. It's got so small I owe Simon an apology. Sorry, Simon, you were right and I was wrong. And you're very clever and I'm very stupid. It shrinks. How amazing. It actually shrinks so much it fits in one hand. But then the heat from my hand wants it up again. And it returns to its original size. And it seems that that is nearly always true of almost every substance you look at. Almost everything you look at, if you cool it down enough, it will shrink. Gases shrink loads. So we call it a law of science. When we cool things down, they shrink. And we name our laws of science after the clever scientists who discovered them. So this now is Simon's law of shrinking stuff. This is our big round of applause. No, well at least every boy learns as soon as he jumps in the sea for the first time, when we cool things down they shrink. When we cool things down they shrink, when we warm them up they get bigger again. Other things happen as well, you notice other changes, pop that there. I've got here a bit of astronaut equipment. Maybe you need to get some air to breathe as an astronaut. Here's your breathing tube. Have a little breathe. It's soft and bendy and flexible, which is handy because you want it to be able to move around. We go into space where it's really cold and woohoo! That's a little weed to get so excited. Actually, I've often wondered why we call it having a wee. It's good urination, you know, scientifically micturation. But we say having a wee. I think it's little boys go wee, wee! This is the warm end, it's all soft and bendy. This is the cold end. It's much, much harder. It's so hard that if we try and bend it now, it will just snap. And to give you an idea of how hard it is, we can take the same rubber, like this, cut with a little pointy bit in it, it's the same bendy rubber, and we're going to cool that in the liquid nitrogen. Meanwhile, whilst we do it over here, I have a lump of wood. There's another lump of wood. The rubber is still rubber, it hasn't changed into a new substance. It's just got very, very cold. And for the clever people who know about molecules, when it gets cold, the molecules move closer together. And it means they can join up a bit stronger with each other. They can bond more tightly. And that's what makes it harder. Oops. So now it's very cold, I have to be very careful. But you can hammer rubber into wood if you make the rubber cold enough. DIY enthusiasts be warned. This is not a recipe for cheap nails. You need to keep your room at minus 200 degrees Celsius for this to work, because as soon as it warms back up again, it goes back the way it started and becomes soft and bendy. It's what we call a reversible change. It reverses back. So we know what happens to rubber. What about what happens to human beings? Well, it's still too dangerous to put someone in space, so we're going to send a stunt banana instead. This is Barney, our SAS trained stunt banana, and we are going to find out what happens to him if we send him into deep, chilly space. Are you ready, Barney? You will now bungee jump on the count of 3. Ready? Ready! 3, 2, 1. Woo! In slow motion, banana somersaults. Woo! Chill for a couple of minutes. Whilst we do, I'd like you to make a prediction. What now do you predict would happen to my fingers if I stuck them in the liquid nitrogen? Would they get bigger or smaller? Harder or softer? Would they freeze and drop off? Yes. Okay, well just in case we'll catch any broken bits in a rubber glove. Let's have a look. So we'll pop our fingers in. Now, if you've ever had a wart frozen off, you know, or a verruca, you know the stings. I can't hold it very long. Ow. But hopefully, ow, ow, it's long enough for you to see a shrinkage. Okay, are my fingers smaller? Are they harder? Oh, it sounds harder, but let's test and find out if they really are harder. Yes, indeed. Much harder. You've all been very lucky this afternoon, because I can only repeat that experiment one more time.